All right, so for this video, we're going to be talking about inequalities, how to graph them, how to live with them, that sort of a thing. The fun thing is if you've learned how to graph a line, you know how to graph these already, for the most part. So here we go. I'm going to take a couple of examples here. Let's see, the first one, let's go ahead and we'll take one that looks like this. X plus 3y is less than or equal to 3. So there's a couple of different ways that you can do this, but both of them kind of rely on this idea that you have two pieces to this solution set. The first piece is called the boundary line. This is where the absolute end of the solution set lies. You will either include it in the case of this one where it has or equal to, or you will exclude it in the case where you get just the less than or the greater than symbol. Excuse me. So you can, in cases where it's easy, you can use your ideas from just allowing x to be something and finding what y is. Most people choose the intercepts. However, you can choose whichever points you wish. The intercepts usually make it easy, but it's certainly optional to do anything. Now, I'm going to go ahead and do that here. The other second option is if it's going to be kind of a nasty equation to use that, like you're going to get fractions or something weird, what you can do is you can go ahead and put this into the slope-intercept form, and then hopefully one of your intercepts is nice, like the y-intercept would be handy. Either one. It does not matter which you do. So I'm going to go ahead and I'm going to choose 2 points on this line. Now, as I tell my students, only 2 things scare the shit out of me about algebra. The first one Einstein was famous for in a lot of his papers, and I see him in a lot of papers of the truly smart people, and it usually reads like, it is easy to see that, and then they go on and on with about 40 years worth of work in 3 lines. It's not easy to see that except for you and 3 of your closest friends. The rest of us have no idea what you're talking about. So that's the first thing. The second thing is choose. Inevitably, this is a loaded statement because it's saying choose this, and then I'm going to give you a laundry list of exceptions. So I'm just going to simply tell you, choose. You can't choose wrong in this. You just have to choose. That's it. So that's kind of nice. So I have 2 things, my x and my y. Choose a value of x, whichever one you wish. It does not matter. I personally prefer to make it convenient. There are certainly some versions of this that you can use to make it more convenient. But most often, 0 is incredibly convenient. So I'm going to go ahead and choose x to be 0. And when I do this, what I'm really going to be graphing is x plus 3y is equal to 3. This is going to be my boundary line. This is going to be the absolute edge of my solution set. The equality is the boundary line. The inequality is the shading. So we got to get out our crayons. Okay, so I chose x to be 0. So with that being 0, adding 0 to anything just keeps the anything. So now I got 3y is equal to 3. If I divide both sides by 3, or I can just guess, 3 times what is 3? It'd be 1, so y is 1. So if I guessed x to be 0, then y would have to be 1, and there's one of the points. We can go ahead and mark this. I'm going to mark it in purple over here on this graph and get the point 0, 1. So there's our mark right there. And then we're going to go on and choose something else. Now I could choose x equals 2. That'd be fine. It's certainly possible. It may not be easy, but it's possible. So you can choose whichever value you wish. Again, there are typically easier ones to work with. I'm going to go ahead and make 0 for the same thing, except I'm going to choose y to be 0. So I'm going to allow y to be 0. When that happens, then I'm going to get x is equal to, sorry, jump way ahead, my apologies. X plus 3 times 0 is equal, again, the boundary line, equal to 3. 3 times 0 is just 0. X plus 0 is just x, so x is equal to 3. So my corresponding x is 3. So I've got 2 points now. And I'm going to go ahead and graph that in bright green. So 3, 0 in bright green. So now I have these 2 points. I know, I understand what's about to happen, but my teacher makes me have 3. I know. It's not because it's necessary. It's a checkpoint. to say, if you screwed it up, you'll never know with 2 points. If you have a third and they all don't agree, the proper term is they are not collinear. But if they don't all agree, being on the same line, one of them is wrong at the very least. So you do a third point to check to make sure it's actually on the line. I'm going to play dumb, and I'm just going to assume that I got it right the first time. Okay, so now I have a bright yellow here. We'll connect the dots and sing the song. Connect the dots, tra-la-la-la. If you don't know where that's from Pee Wee Herman's Playhouse. I'm old, what can I say? So we go ahead and connect the dots. And now I kind of cheat. And I'm sure that teachers out there would be like, stop telling them to cheat. I understand that. It's not really a cheat. It's just an alternative way of doing it. I would graph it the same way, even on paper, even if it were a strict inequality, so we had to have a dashed line. The only thing I would do is I'd go back and I'd erase a little bit, and that's it. I wouldn't dash it up front because I'm terrible at drawing. And so I can draw a straight solid line a lot easier than a straight dashed line. Anywho, so now I have this line. This is our boundary line. So this is going to be the boundary. We'll put boundary up here. Boundary. This is the line. X plus 3y is equal to 3. We need x plus 3y is less than or equal to 3. So we have to find out which place is the less than. I'm not too bad when it comes to these. That's pretty good. When it's not a nice shallow slope and it's not perfectly horizontal or perfectly vertical, I'm okay. As it starts approaching the vertical, which side is the upper and which side is the lower, I'm not a fan. Don't go with that at all. So what I do is I use something called a test point. Now, I have 2 choices. Just 2. The solution is going to include the line on either way. But I can either shade one side of the line or I can shade the other side of the line. Those are my only 2 options. It cuts the plane in half. So I'm going to create a test point here. You can choose any point you wish that is not on the line. So as long as it doesn't fall on this yellow line, we're good. I'm going to choose a test point. I always choose the point 0, 0 unless it's always on the line. It's easy. I mean, what can I say? It's very simple to calculate. So I'm going to choose this red point right there, the origin. If the statement is true, we shade the side that the point is on because it's part of the solution set. If our test point is false, we shade the other side. All right, so here we go. Let's test it out, see what happens. So I'm going to take my inequality. This is my original inequality. I'm going to go ahead and put in 0, 0 for y, or x and y. All right, so notice that it's not going to be on the line. And we're going to put in 0 plus 3 times 0 is less than or equal to 3. Is it? Well, 3 times 0 is 0 plus 0 is 0. So is 0 less than or equal to 3? Yes, it is one of them. It is only required to be one of them. In fact, it can only be one of them by something called the trichotomy property if you're really anxious about it. So, because we chose red for that point, it is true we shade that side of the line. All right, so what we're saying here is we're saying not only is this boundary line part of the solution, but so is everything on this half, on the half of the plane below this line. And that's it. That's all inequalities. Literally, that's it. Wash, rinse, repeat 47 bajillion times. There's nothing more complicated than that. It's a little bit funky to do this algebraically because you end up basically saying the same thing. It's usually a little bit easier to show it visually, so that's why we tend to graph. Okay, so just remember these 2 rules. And this is just to signify the difference between is less than or equal to, meaning the or equal to, or the case where it's less than, and that's it. So this is an or equal to, that's why you get the solid line. If it's, according to this first rule, if there is no equal, then it's a dashed line. The way I remember this, look at the or equal to. It has a solid line, therefore it gets a solid line. That's it. The other one doesn't, so it doesn't. That's how I remember it. Okay, well, let's try another one. What's the worst that can possibly happen? Don't answer that. It's probably going to happen. Okay, so let's try one that looks like this. 1/2 x minus y is greater than 1. That's not so bad. Again, you can do it however you wish. Now, in this particular case, I am going to yeah, I'm probably doing that too. But I am going to work this through so that we're going to move it into the slope-intercept form. It's going to help in the long run. So let's help ourselves out a little bit. And the reason it's going to help is that I don't have to worry about the half later. I can use the half to my advantage. I'm going to go ahead and I'm going to do this probably a slightly different way than most people do. Instead of subtracting the 1/2 x from both sides, I'm going to go ahead and add y. I do not like to divide by negative numbers, so I choose to not. So that's going to give me 1/2 x is greater than 1 plus y. Then I need to move everything away from the y, and so I go ahead and I subtract 1 from both sides. That's going to give me 1/2 x minus 1 is greater than y. If you don't like this, that's perfectly fine. You can flip it. So we can just rewrite this as y is less than 1/2 x minus 1. Either way does not matter. Okay, if you chose to move the 1/2 x and then divide by negative, that's fine. You're just going to have to remember to flip that inequality. That's why I choose not to do it. So now I have it in the slope-intercept form. I am guaranteed a couple of things through this format, which is kind of nice and it's kind of helpful. I am guaranteed that it passes through the point 0, -1. That is the y-intercept, and that comes from this piece right here. Also, I am guaranteed by virtue of this form that I have a slope of 1/2. So for every positive 1 in the y direction, I'm going to go positive 2 in the x direction. That's how slope works. So remember, slope is the rise over the run, or the y's over the x's. So I can start at the point 0, -1. So I put my point right there. And then I can read my slope into it, which says I go up 1 on the y, positive 1 on the y, positive 2 on the x, drop a point. Positive 1 on the y, positive 2 on the x, drop a point. Positive 1 on the y, positive 2 on the x, drop a point. And you'll notice they're all right in a line. The slope is consistent throughout the line. All right, so we go ahead and let's see, that's going to be way over there. So I'm going to come over 12, drop 6. 1, 2, 3, 4, 5, 6. I'm doing this for my benefit so that it's easier for me to draw the straight line. Okay, we'll go ahead and line it in yellow again. Starting from there, draw the straight line, line everybody up, and let it go. All right. So this is our boundary line. This is 1/2 x minus y is equal to 1. That's our boundary. You'll notice that we have a strict inequality, so I can't have it be a solid line. It's got to be dashed. Well, like I said, it's easier to create a solid line, so I just go back and I go, no, erase, erase, erase. When I do this, I always do it in pencil, so I can just go back and erase. There, look, a dashed line. Ta-da! Maybe better clean it up in here. Okay, so now, again, I'm just going to choose a test point. If you can look at this and see which way it's going to go, perfectly fine. I can guess which way it's going to go, but I'm not confident in myself to be able to do that all the time. So I'm going to choose a test point, and the test point I'm going to choose is this point right here because it's easy. It is the origin, which means it passes through the point 0, 0, making x 0 and y 0. So that means that if I go back up to my original inequality, 1/2 x, 1/2 times 0, because x is 0, minus, oh, come on now, 0 is greater than 1. Is that true? All right, so 0, let's see, 0 is greater than 1. True? Now, question, did you choose the right way? My guess would be probably not. Most people will look at this and say that, oh, look, it's got to be on top because it's bigger. Not really. There's a certain other thing that must be true. I'm going to let you figure that one out for yourself. But here we go. Is 0 greater than 1? No, it is not. It is false, therefore, that 0, 0 is a solution, so I shade the other side. I'm reminded of Moby's song South Side with Gwen Stefani. Those that are around in the 90s probably know what it is. Anyway, so that's graphing inequalities. They all work like this. Nothing else changes. You can utilize a test point or you cannot. That's fine. My advice to you is if you are not going to utilize the test point, you just don't like it, it's confusing, then make sure to put every single one of these inequalities in slope-intercept form. It will save you the hassle of trying to guess which side is which. So if you put it in slope-intercept form every single time, it will tell you the correct side every single time. Otherwise, you got to do like me, and I just test point it, and I'm good. So that's it. That's inequalities. I'm going to do a couple more, and you're going to see they work the same way. The only difference being is I'm going to do ones that are vertical and ones that are horizontal. And then I know how to do upper or positive or negative on that. So if it has to split, so like it's greater than, I can see the difference between there. You can still run a test point, and I'll show you how to do it. But if you want to stop this right now, that's fine too. I'm just going to make some up. All right, here we go. Let's try something like 3x is greater than 6. Okay, if I solve for x, then x is greater than 2. All right, so I'm just going to go ahead and say, well, I need to really graph x is equal to 2, which is a vertical line. So the x-coordinate of all of my points must be 2. My y-coordinate can do whatever it wants. The way I explain it to my students, and I have college students, so it's a little bit different. If you've ever had a boyfriend or girlfriend, look at what's happening here. I'm going to do whatever I want to do. So I'm going to do my thing. The question is, what's my ex-boyfriend or ex-girlfriend going to do? If you've been married, you can put your ex-wife or ex-husband. That's fine. I don't care. But, all right, so I'm doing my thing. What do they do? I don't care. I really don't care what they're doing. I'm doing me. So they're doing that. Is that true? Sure, why not? I'm doing me. That's all I care about. I'm doing what I'm doing. The rest of it, yeah, we're just going to go ahead and put in any kind of number. So if you're really looking for numbers and you have to put these in, that's fine. We got 2 pairs now. We can call it 2, 1 and 2, 4. And you'll notice it's a vertical line passing through x equals 2. So we just go ahead and draw this vertical line out. And that's it. And so now you'll notice that it's not equal to. So it is a strict inequality. So I just go back and there, I made a dashed line. I did it. I did it, coach. I did what you wanted. I'm also certain that some teachers would be like, why are you doing that? Well, because some idiot on the internet told me to. It works, doesn't it? Don't tell anybody. All right, so now I don't really need to test this, but it's because I've been doing it a while. If you would like to test this, just pick a point, not on a line. I always choose 0, 0 if I can because it's just easy. So remember that x is 0, y is 0 in that case. There's no y, so nobody cares. So I just go ahead and I plug that into my original inequality. 3 times 0 is greater than 6. Is that true? 0 is greater than 6? Not so much. Not so much. So the left side's not going to work. The right side must. Now, I knew that it was going to happen this way after I solved it here. X is greater than 2. Okay, well, what number is greater than 2? 3. Which side is that on? The right. It's going to go this way. Those I can manage. The others, I don't trust myself. Not even a little bit. So again, that's all there is to it. That's all there is. All right, last one, because this is going to be a horizontal. So I'm going to say something like 1/3 y is less than or equal to 3. Okay, so here I'm just going to go ahead and rather than start guessing numbers and that sort of thing, I'm just going to go ahead and I'm going to solve this for y. I'm going to multiply both sides of it by 3. When I do that, 3 times 1/3 is 1, so I just get y. I do not have to flip it because I'm not multiplying by a negative. So y is less than or equal to 9. So all I got to do is find y equals 9 up here. 2, 3, 4, 5, 6, 7, 8, 9. Okay, well, what's the y value? 9. What's x doing? I don't care. It's apparently not involved in this at all. So happens. All right, so now we have an or. So we have a less than or equal to. We can include the line, leaving it as a solid line. Now from here, less than. So it's got to be below. Pick a y less than 9. 8. Okay, where's 8? It's right here. Okay. Ta-da, you're done. That's it. If you put in 0, 0, that's fine, because you're going to put in 0 for y, you get 0 is less than 9. It's true. So you just shade that side. These are inequalities. They're not that bad. So when you're thinking about it, it's like, oh my gosh, something else. No, shh. Just get out your coloring books and your crayons and be fine. Life is good. By the way, it's a true story on the crayons. I love using crayons in these things. We'll see you in the next video.